So, hello guys and welcome back to the next lesson. So in this lesson we will do the VDB meshing and the masking for later for the rendering part, so we can use the mask to blend some materials, and we will do some outer forms to scatter onto. So let's get started. First of all, what I want to do before the measure, I want to make a split here and create another null. So this is like basically our base geometry here. And what I want to do is like call that out for VDB. And now with that null we can create basically our VDB remeshing. So let's get a VDB from polygons. No, not particles. Not particles. VDB from polygons, yes, and we will remesh that, so basically to voxels, maybe 0.001 to get a really high, basically a really high representation with voxels. And the next thing what I want to do, I want to just copy the VDB from polygons, and I want to do the same way on our copied geometry. And let's give that a second. That can take a while, maybe not. Yeah, okay. Let's just go back, and I think because 50,000, I think that's alright, 50,000. So we got like 26,000. Let's use a little bit more here, because we will delete them anyways. So let's go maybe to 0.0025 for now. And we will use that voxel representation in combination with that voxel representation, or that voxelization or VDB mesh, to basically combine them. So VDB combine, where is it? VDB combine A and B. And what I want to do is SDF union. And then of course what you can do a SDF subtract and convert that, so you will get two separated geometries. You can use that, but what I want to do is like connect them and then later separate them with a mask, basically in the rendering process. So we can convert that back to polygons, and we will get a pretty high resolution mesh here, 5 million polygons. I think that looks pretty cool already. What I like about these rectangle shapes, I think they look pretty cool in the rendering, especially with glass, for example, with a refractive material. And what I also want to do, I want to place that here, and I want to convert that back to polys 2. So just the scattered geometry, and you can get a little bit of adaptivity involved here, because we don't need such a high resolution for the mask from geometry. And we want to mask this geometry by that geometry. And now I think that will take a while here to basically to process it. Of course you can do it what we did with the last chapter. You can do just like an attribute transfer, you can do that too. but I will just do it with a mask from geometry now, because I think that node is pretty handy too, and I will run that through, and I will see you in a second. So guys, now it's finished. I think it took like 1 minute or so, and now we can already see what I changed is the mask from geometry. I just changed the radius to 0.01, and now you can see we will get this really cool masking effect. Of course you can blur it out maybe a little bit if you want to, but basically we now got our mask and we can work with that mask. I will just type here out final geo, so we are finished with that geometry. And now of course you can try out other copy the points. What I did for one style frame is basically a polywire, so like little lines. You can copy them on here too. Of course they're way too long, so 0.01 for example. And a polywire. So to get more like an extruded example, and you need to change your radius a little bit. So I think that is pretty cool. And what I forgot what it will do, of course, is our p-scale here, our little p-scale setup. Maybe something like that, and the length. So you can try out something like that too, and you will get pretty quickly cool results. And for now, for the p-scale, basically we want a different p-scale for each point, and let's place down attribute wrangle, create p-scale, p-scale, and we will do that with floats. So we will create a float and call that rand, and that will equal to rand, so the random function, just like in WOPS, will generate a value from 0 to 1. So add ptnum, this is our point number, plus 1, this is our to get rid of the point 0 will not have a seed, but with plus 1 the point number will get shifted, and that multiplied by a channel float called seed. So we will get a random value for each point. Then we want to fit that value. So rand equals fit 01. We can use the fit01 function because the random expression will always put out like a value between 0 and 1, so we don't need to fit the incoming values, we only will fit the outcoming values. What we want to fit is rand, comma, and then channel float, and get 1 min, and we can copy the whole thing here, comma again, and max. So we will fit the random value between a minimum and a maximum channel, and after that we can use f at p-scale equals rand times channel float, and with the times channel float we can make a multiplier, so we can multiply our basically our value for the p-scale by a overall multiplier, and then just click on create spare parameters, get the seed, get the minimum value, the maximum value, and the multiplier. And now you can see we've got different scales on our geometry. For example, same for our other geometries here. You can change the seed, you can change, for example, the minimum value, the maximum value. So I think that's pretty good to have like to have a random distribution because if you got like this uniformal distribution over your geometry, I think it will not look that good. And of course, if you look at real-world reference about minerals, you will get like basically the same thing. Cool, so we did that, created our p-scale, did our mask, and we are finished with that lesson. So I will see you in the next lesson with the rendering part and with the setup part for the Redshift proxy part. So basically rendering plus Redshift proxies. So I will see you in the next lesson.